Good morning, my dear students. Today we will perform the first practical. I hope I'm audible to you.
Yes, ma'am.
Okay. And I'm sharing the screen. I want all of you to perform the practical today, and you should show me the output. Okay. Already we have discussed, but very quick way. I'll be, explaining the things again because already we have discussed these things in the um, practical in the theory class. Correct. So we will start with the write up first. I've already shared the write up to you in Google Classroom. So we are performing the experiment number A, regression analysis. Okay, what you have to do here is experiment number is A because it's beyond syllabus experiment. Regression analysis, performance date, you have to put today's date. Okay, that is 18/1/22. And by next week you have to submit this write up. Okay, this is how it will go. So date of submission will be next week. You can write the roll number. Okay, I'll be allocating the marks in the Google Classroom. Okay, the aim of the experiment is to study and implement the linear and non-linear regression techniques and analyze its effect. Okay, that's why the name regression analysis. The objective of this is to determine the values of parameters for a function that causes the function to best fit a data set observation that you provide, and to explore the relationship between the dependent variable and one or more independent variable, which we also called as predicator or explanatory variables. So this we are performing, the software which we are using is MATLAB. We are having campus wide license for MATLAB. So with this experiment we will be able to understand various machine learning techniques such as regression analysis, and to get the insight when to apply a particular machine learning approach, that we will be understanding. Correct. So analysis we will be doing linear, non-linear, which one is best and why, and you'll be able to understand and apply the concept of linear model for supervised learning. Okay, regression analysis is a supervised learning technique. Now the PO mapped is these are the lifelong learning and everything you will be getting through this, that is engineering knowledge, yeah, obviously. Then problem analysis, correct, then design and development of solutions and conducting the complex experiments. Modern tool usage, here we are using MATLAB, and it you can do it individually this and show me the output, and it is a lifelong learning. You can try this experiment for various applications. Okay, regarding the theory, what is regression? Can anyone say what is regression? Hello.
Prediction.
Yeah, it's prediction or statistical process of estimating a particular relationship between the variables. Okay, here also it is written. So this kind of questions can be asked even during the practical, and just instead of saying a single word, you have to try to say it's a statistical process of predicting something or estimating the relationship among variables. What can be the variable? Dependent and independent variable. Okay, already in the class I have discussed. That's why I'm not going in depth of it. Correct. And you have to read this. Okay, it includes many techniques for modeling and analyzing several variables, that is focusing on relationship between the dependent and one or more independent variable. That is, regressions can be a1x plus a naught, that is equation of a line. Similar way, linear regressions can be a1x plus a naught. What is this a naught? A naught is the intercept, which is a constant here, and a1, okay, a1 here is the slope of a1 likhna hai, should be a1 is the slope of the line. Okay, so y is the independent variable and x is the sorry, y is the dependent variable. Y is depending upon x, but x is not dependent. X is called independent variable. Okay, this is what you have to understand for every case of 1 in x, y changes the equal amount of a1x plus a naught. Some relationship can be perfectly linear and that fits the equation exactly. Meaning is, with the help of a line we will be able to fit the or find a relationship for predicting something or estimating something. So there are in regression analysis there are two main methods. We call it as linear least square method and curve fitting method. Linear least square method we are having in linear least square method is based on square of the distance, that is error, rather than the just distance nahi hai, square of distance hai. Okay, iska meaning we are going to discuss in practically. Okay, that is I was telling you that. Okay, I'll just execute it and I'll tell now why it is least square method. You can see that you have to go to basic fitting. In basic fitting, if suppose I'm taking linear, okay, in the first case you have to perform linear mathematically and programmatically you have to confirm. So this is the best fit line or regression line and the error estimate. Okay, if you see the error estimate which I'm showing bar graph, you can see the variation from actual to the regression line. Regression line is prediction line. Prediction line ke hisab se it is, there is variation, deviation from actual to the predicted. That is error. So this error is not directly taken. Now here with the help of square se le lete hain hum log. Okay, this is what I'm trying to say. Okay. Now I want you to read this because this is not very simple understanding. You will be understanding that why we are doing this. The linear least square method is based on minimizing the square of the distance. Distance का square कर देते हैं, which is nothing but error. We call it as, that is deviation from the actual to the predicted. इसका square ले लेते हैं. Why? Can anyone say why? It uses the criterion of attempting to make the least amount of total error in the prediction of y from x. That means, more technically if you are speaking, the procedure used in least square method generates a straight line that minimizes the sum of squared deviations of the actual values of the predicted regression line. Meaning is, if suppose in our case, I'll just take the here. So this is the predicted value. This is the actual value. Correct? There is a deviation from this. Y is 19, whereas here y is 14.7 or something. So there is a deviation. So that deviation is this. For x is equal to 1.5, there is a deviation of around 5, 4.3 or something, whatever. Okay, so that much deviation is there. Instead of saying that, now we are saying that there is a least square method in which what we are going to take the square of that. Square le lete to the error will be minimizing, because now I'm going to discuss you with the concepts. Okay, how the square will be minimizing. Just give me a minute. What I will do is I will be taking the this itself. Okay, so yeah, so in regression, you can see that this is the regression line. So there is a deviation from this is the regression line. Okay, that is prediction line. So deviation from the actual value to the predicted value, correct? So this is nothing but we are going to discuss now this deviation. I will be discussing with the help of suppose point with the help of some numbers. Okay, suppose this deviation I am assuming that 0.5 hai positive mein. This is maybe here the deviation is 0.5 in negative direction. So positive and negative direction is not iske below that, correct? That is not important for us. This is negative, right? Sample say predicted line say there is a difference. So this is negative, this is positive. So ये दोनों को nullify करना है. So square I'll take 0.5. If I take the square of it, what it will become? 0.25. So the error effect is reduced. Least square method, error is squared, and then we will be doing the summation of it. Okay, actually this is how it works. Okay, this is okay. So this is what I was discussing with you. So what we were discussing, yeah, right here A1. Okay. So least square method mein what we are doing, we are taking the minimizing the square by minimizing the error by squaring it. Okay, so in least square method generates a straight line that minimizes the sum of squared deviation from the predicted regression line. In a line of the best fit for a group of points, it seeks minimizing the sum of all data points. So summation we will be doing for all data points, and it is the linear form. So you can see that this is the equation of a line, correct? So in linear form equation of a line we will be getting. Iska derivation part I am skipping. That's why you could see that y is the dependent variable, x is the independent variable, a naught is the constant, and a1 is the slope of the line. Now you can see that a1 and a naught is given by the equation a1 equal to n into summation xi yi minus summation xi yi summation y whole divided by n into summation xi square minus summation xi the whole square. Correct. So a naught is equal to y bar minus a1 into x bar. What is y bar? Is the mean of y, and x bar is the mean of x. So similar way we can do curve fitting method. So instead of linear relationship among the two variables x and y, we are involving our original physical system that is supposed to be in maybe in quadratic relationship. Example is y is equal to ax square plus bx plus c, quadratic equation. Correct. So where a, b, c, these are all constant value. This means that all our plotted data should lie on a single parabola. Correct. So that is what we were discussing here with the help of parabola. Okay, if suppose I'm taking quadratic, so what will happen? The equation, you can see that minus 3.5 x square plus 8.479 x plus 12.1, which is a parabola. Now I will remove the linear so that you can see only the the parabola or quadratic equation, and it is better. It is all the values now. You can see that the errors have been minimized. If you do comparison, then you will easily able to understand. Otherwise, we can see that the error has minimized compared to the linear regression. Okay. Now we will come to the point. Okay. So how you are getting that or another linear parabolic equation, and we are according to the equation we will be plotting the graph. Again you can see that there is a variation from or deviation from the that is nothing but what is the deviation? We call it as error. What is that error? Actually we call it as residuals. What is residual? Actual value minus the predicted value. So actual value is this minus the predicted value. Here you could see that this is actual value is in negative side, so that's why it is minus. Okay, here also it is minus. Here it is above the predicted line, so that's why it is positive. That also you have to note down. Okay. So the next point in this is what you have to understand is, so these are the two curves. So curve can be anything, not only quadratic, it can be cubic or 4th degree, 5th degree, 6th degree, like that it can be anything. What are the applications? Weather forecasting such as rainfall in a region, or navigation of robot, response of response surface design such as optimizing something, the quality of a product. Then trend analysis can be linear or maybe exponential. Finance or in economics, in environmental science, etc. we will be using this. Now I will focus on these steps. Okay, so these steps are very important. As it is, you have to follow. This is the algorithm steps. That is, accept the total number of data, accept the number of x and y. Okay, number of value x and y. So you will be doing this. I will not be explain. Either you can use it in this way, accept a number of this thing samples x and y directly like this, or maybe you can accept by accepting the input from the user. Correct. N is equal to input, enter the number of data for I is equal to 1 to n, xi and 1 by 1, you can accept the data. Both are okay. Now the next step is, after accepting the data, next one is x and y accept ho gaya, display the plot using scatter plot. So how you can do that? You can scatter x comma y, and in that you can see that title regression analysis, x label is x data, y label is y data. So like that, if you see here, you can see that I'm just removing the rest of the things. Okay, so now we'll take this and remove this. Even first I'll remove everything. So you can see that this is the scatter plot, in which scatter means this circles which you could see. It is like different points. If you click here, you will get the same value. Okay, scatter plot. So how many samples we are having? 6 samples. So that will be there. And regression analysis, the title, x axis and y axis, x data and y data. So uske baad mein kya hai? What you have to do? Display the scatter plot, calculate the product of x and y. So how to calculate? Why we are doing this? Because we to get the equation, correct? So calculate the product of x and y means how you will be doing that. You can do it in any way. For I is equal to 1 to n, xy I, xy of I means xi into yi. Similar way, x square I. So the same thing what we have done in the problem, the same thing we are doing it here. So calculating the product of x and y, correct? x into xi yi summation, फिर summation करना है. Similar way, xi into yi, then xi square. So ये सब कुछ करने के बाद next one, square of each of the x, ये दोनों हो गया. Okay, इधर here xy and x square. Then after that you are having directly what you can do is you can get the sum of all x, sum of all y, sum of x into y, correct, and calculate the sum of all square of x. So now we are doing that only. So you can see that directly in MATLAB we are having the ready-made function, or if you want you can use it in any way. Sum of x, okay, sum of x is sum of within bracket x. इधर variable मैंने sum x लिखा है because we cannot write of x. Sum y, then x square के लिए I'm sum of x2, that is sum of x square, sum of x into y, summation x into y. Okay, so it is doing the same way as that of the calculation. Okay, then afterwards okay, you can see that the same problem we are solving. What we have to do, I'll repeat, x and y will be given, then all x का sum, y का sum, x square का sum, x into y का sum. ये सब किसके लिए? Because so that we will be getting these values, correct? In the next one you can see that summation xy is this much, summation x into y is this, summation x square is this, summation xi whole square is this much. So y is equal to a1x plus a naught is our equation. Then a1 is this, a naught is this. So a1 में substitute कर रहा है, you will be getting the value of a1. Once you get the value of a1, how to get the value of a naught? Y bar minus a1 into x bar. What is y bar? Y bar is summation of y whole divided by n. That is nothing but average or mean value. Similar way, x bar is mean of x, summation of x whole divided by n. And is total number of samples. So you will be getting this a1 and a naught. Once you get this, what is the next one? You will be substituting in this so that you will be getting a naught. So once a1 and a naught you will be getting, you will be putting it in the equation, that is y is equal to minus 3.7714 x plus 20.2667. So once you get the equation, next step क्या है आपको? You have to, so ये होने के बाद next one is you will be getting the basic fitting tool. You are going for linear regression. Okay, linear regression में what is expected here? आपको output कैसा होना चाहिए? पहले yeah, I'll just show. So the same equation, a1 is n into summation of xi minus sum of x into sum of y whole divided by n into sum of x square minus sum of x into x whole square, sum of x whole square. Okay, so a naught is ym minus a1 into xm. What is ym? Ym is sum of y divided by n. Like that, I have removed the semicolon here so that you will be getting all these values. Okay, in command window. In command window you should get all these values. Okay, even input भी accept करते हैं हम लोग. So that what I will do is input का भी ये निकाल देते हैं, so that I'll remove this and execute it once again. Okay, so I want the same thing, all of you have to execute and show me the output. So you can see that in the output x, y, okay, then all values. So this is the expected. आपको so क्या करना चाहिए, ये कॉपी करना है and you have to put it in the here, okay. So linear regression straight line का output. Then you can even adjust the line, all lines, because ये बहुत ज़्यादा ये occupy होता है ना. So what you can do is you can make it this one so that it will be properly seen. So I am not taking the time for doing that now. उसके बाद में आपको क्या करना है, this one, okay. How to get this regression analysis line? So for that what you can do, you can go for this in tools basic fittings, in basic fittings, in basic fitting, go for this linear. Okay, so you will be getting this. So for copying this, edit, copy figure, okay, and paste it here. Sorry, I didn't maybe copy it. Edit, copy figure, then you can come here, paste it. Okay, so this is how you will be able to paste the diagram. Next one is non-linear, that is parabola. Parabola के लिए कैसे करना है? So I'm just deleting this. Okay, only for parabola. Or quadratic equation, you can think about it. For that, go with this. Now instead of this linear, you remove this and go for only quadratic. Now the same way, edit, copy figure, okay, okay, and you can go for pasting it in the Word document. So you have seen this. This is regression analysis for quadratic. Next one, we have to do the comparison. Correct? Comparison of linear and non-linear, parabolic analysis. So for that, what you have to do? You have to go here and go to the basic fitting tool. You need to take both linear and non-linear. You have to take both linear and non-linear. Then you have to go for the error estimation, which is residuals, and go for the bar graph. So with this, you are getting the figure, copy figure, and you can paste it here. Okay, so this is how we will be able to do the experiment. Experiment होने के बाद what is expected as output or outcome is, first one what you have to do, these are the output: linear regression straight line, then non-linear regression you can go for the parabolic value, okay, and the third one is comparison between linear and non-linear regression with this curve. And this you can paste it as it is in the Word document. Similar way, the program also. Okay, I'm just you can directly paste the whatever the value you are using it here. Suppose this one, okay, n is equal to 6. If you want, you can even remove that, so that the total number of inputs and everything. And conclusion, what is expected in the conclusion is, you will be doing, these are the 3 questions which you have to perform. Linear and non-linear regression analysis, what is that? If you read in these 4 books, all soft copies I have given to you. you will be able to write the answer. Explain the need of it with an example. And this is another question, that is least square method m1x, the same thing which we have done it in the class. So this you have to perform. So mathematically and programmatically you are getting the same answer. That will be first for linear, and for the analysis purpose quadratic you have done it. And for that, in the first problem, which one we are getting better solution? The quadratic is showing a better solution. From the graph, that is third graph, it is, we can conclude that is this graph, we can conclude that residuals are less. Within bracket you can say error estimation is less in quadratic. That is why for this particular problem, quadratic is a better solution or better prediction than the linear regression. So this is how the conclusion should be. Why also you have to write. So conclusion you have to write handwritten. Okay, you have to upload the entire thing along with the question answers. Question answers in the sense 3 questions are there. One is theory, the other 2 are problem. Okay, all the questions are already been discussed, and I think we have even discussed that in the theory class, and it is already uploaded in the PPT. So what I suggest is that I want all of you to perform this practical and show me the output. I'm giving time for that. Any doubt, if anybody is having, please let me know. Okay, already this PPT I have uploaded in the Google Drive. So it's your turn to so you can see that the steps are there, the calculations are there. This is the second one. Okay, so this is the third one. And overfitting also we have already discussed, so I'm not discussing because I cannot go with many higher degree or complexity should not be too much. This is the next point which you should understand. Since I have discussed in the class, I'm not discussing. Suppose 5th degree, if I'm taking it, so you can see that the error will be very much less. You can see that the 5th degree is with another color and the residuals are very, very zero. Correct, it is touching all the points, but this is the complexity. You can see the equation. If you see the equation, it is x raised to 5. Okay, x raised to 5, 5th degree means 5th degree polynomial means x raised to 5 term will come, correct, but the complexity will be too much, so it may happen that it is overfitting. There is no need for that. So theoretically also we have discussed. Now programmatically also I'm saying that this is many times it is not needed. Maybe with a quadratic or cubic this is fine for getting the final solution. Okay, so that is what we have discussed here with the concept of so best fit is always good. Just write best fit or appropriate fit. Overfitting is not needed. If you go with higher degrees of polynomials, there is a chance for overfitting, and the complexity also will increase, especially the time complexity, and sometimes even the space complexity, since the variables are increasing. Underfitting is something which is actually not too simple, and there is many times there is more number of variation or the error. So we will not accept for underfitting. That's all from my side. Any other thing you would like to understand, or if you have any doubt, please let me know. Hey, kya kisi ka doubt? If not, I'm going to stop this recording.